In this video, I'm going to show you how to answer question number 8 from the chapter 4 purple paper. This question involves dilution. The question asks, when nitric acid is purchased in its concentrated form, its molarity is 15.9. So that is a very, very high molarity. An experiment requires 500 milliliters of 6 molar nitric acid. How is the solution prepared? So what we're doing here is we will take our initial solution, the one with a molarity of 15.9, and we need to add water to it in order to dilute it so that it is 6 molar. It has a 6 molar concentration, and we only want to make 500 milliliters. So right off the bat, when we're dealing with molarity, you can instantly say, okay, that's moles per liter, so I'm going to take my milliliters, and I'm going to convert it into liters by dividing by 1,000. So you should highlight or circle the important information. We're given the molarity of the initial solution. So solution 1, we are given its molarity. And we want to know how the solution is prepared. So we need to know how many liters of solution 1 we need in order to create this second molarity and only 500 milliliters of it. So solution 1, we know that molarity is moles per liter. We have the molarity given, and the whole goal is to figure out the liters of solution 1 that we need. So the question here is, how do we get moles? Because once we have moles, we can figure out liters. So let's look at solution 2. In solution 2, we are told the molarity, we are told the liters. So we can figure out the moles for solution 2. So once we plug in our numbers, and solve for moles, we should get 3 moles. Notice there are 3 significant figures in each of those numbers, so our answer is also going to have 3 significant figures. So if we have 3 moles, if we need 3 moles in our final solution, that means we need to take a specific volume of 15.9 of our 15.9 molar solution that will give us just 3 moles. So we're going to go back to solution 1, and here's our molarity. And now we're going to plug in, for moles, we're going to plug in our 3.00 moles because we know we need that many moles for our final solution. So after plugging this in, you should get 0.189 liters. Since it gives us milliliters in the problem, we're going to convert this back into milliliters. And we need 189 milliliters of our initial solution in order to form our final solution. So we will take 189 milliliters of the 15.9 molar nitric acid. And then, since we need 500 milliliters, we will add enough water to make it 500. So we're going to need to add 311 milliliters of just H2O. So 311 milliliters of H2O with our 189 milliliters of the concentrated nitric acid will give us our final solution. I'm going to show you an easier way to do this as well. So we know that the molarity of solution 1 is moles over liters, and the molarity of solution 2 is also moles over liters. We also know that our moles are exactly the same number because however many moles we have in solution 1, that's what we want to have in solution 2, or vice versa. So we can solve both equations for moles by just multiplying liters. So it'll be molarity times liters equals mole. And for our other one, it'll be the same thing. Molarity times liters equals mole. And again, these moles are exactly the same thing. Okay, so if those moles are the same thing, then we can just substitute in molarity times liters for our first solution into moles. So what we end up with, and this is called the dilution equation, we end up with molarity of our first solution times the liters of our first solution equal the molarity of our second solution times the liters of our second solution. So starting from here, we could plug in the molarity of our first solution. We could plug in the liters of our second solution and the molarity of our second solution. And then we could solve for the initial liters, and you should end up with the same thing.